Evening, one and all. Thank you for joining us on this Sunday evening for this very special session that the Education Society, IEEE Education Society Kerala section has organized specifically for high school students. We are so happy that we could connect with you beyond your classrooms and we could share some experiences of our professionals with all of you. Today we have with us Akshay Nagarajan. He is going to give a talk on Can Science and Technology Help Save Planet Earth? Akshay Nagarajan is a cognitive science researcher at the University of California, San Diego. He is a master maker. He is an excellent, very prolific researcher, having published several papers. He's also a veteran IEEE member. He has a master's in robotics and automation from Amrita Vishwavidyapeetham, and he has worked in research labs in Stanford University and the University of Michigan, USA. Right now, he's in San Diego, and that's where he's calling from. He has an extensive experience in designing haptic and virtual reality simulators, autonomous robots, delivery drones, and in human robot interaction. His current research focuses on cognition in young children, and he hopes to use his research to create better learning environments in schools. Akshay has set up several makerspaces both at Amrita University and in Amrita Vidyalayam schools and has worked with children extensively promoting maker education. He has won the Stanford University's FabLearn Global Excellence Practitioner Award in 2018. When he's not working with humans or robots, you can find him actively engaged in wildlife conservation. And right now, he's studying Japanese monkeys. Over to you, Akshay.
Sir, your mic is muted.
Perfect. I needed someone to remind me of that. Yes. Well, I'm really sorry. Okay, I don't know why, but it is 6:30 in the morning for me. So you have to forgive me if some of the things I say or the things I do don't seem reasonable at all. It's probably because I'm very sleep deprived right now. But anyway, let me quickly share a few slides. I don't have a lot of slides today, but something to help us with the conversation. Okay. I think I'm sharing now. Yes. Can you see my screen full screen?
Yes.
Yes,
All
sir.
right, perfect.
Yes.
All right. Unfortunately, when I went full screen, now I cannot see you anymore. But hopefully we can pause during the presentation at different parts. So the presentation, usually when I give a talk, I put in lots of videos and lots of pictures and everything. But today I did not do that for a specific reason because this conversation is more about what we believe about this topic and what we believe about what we need to do for our planet rather than seeing what other people have done about it. We do have to take, you know, inspiration from what other people have done, but this conversation has to be about what we believe and then trying to improve on what we think we can do for the planet. So, before starting this, I was starting to think about, okay, wait, why is this even important for us, right? I mean, yes, it's very obvious that we are on this planet and we need this planet for our own survival. But are we actively thinking about this every moment of our life? No, we are not, right? If you're a high school student, for instance, your priority right now would be, okay, how do I go for my coaching classes? How do I get my entrance exam done? How do I get into a good program in engineering or a good program in medicine or some other field if you want to get into that? And these are usually what is your main priority. And it has to be for good reason. That is what is right in front of you. That is what is in the next couple of years for you. So really, that's what you work and work towards. And that's what is important. But that said, we, in our classrooms, ever since we started studying about science and ever since we started you know, working with computers and maybe learning some programming, there is always this conversation that comes up about, oh, what is science? What is technology? What can we do for science and what can we do with science and technology? How can it help us? Right. So before I get into all of this, I want to really unpack what is science and what is technology, because unless we understand science in its entirety and we understand what technology is and how technology functions, I don't think this conversation makes any sense. Right. So when I started thinking about science, I was trying to remember what I remember about science when I was in school. I think science was always, initially it was it's all about learning about the world and learning about how the world functions and how different systems work. And then from that, it went from phenomena, it became, oh, science is about chemistry, science is about biology, science is about, you know, physics, and these are different aspects that we learn. PCM that becomes more important, and then there is math that is involved to substantiate how science works. We use equation, and that is what we know as science. But really, what is science? Right? Science is not the subjects that we learn. Right? The subjects that we learn are a product of science in a way, sort of. Science is actually a way of thinking. If you look at it, if you think about a scientist, who's a scientist, right? So we talk about science and scientists. Scientists are people who effectively are doing science, right? So when you say somebody is doing science, obviously that means science is a process. Science is something that is in action, right? And you're able to do that action, and that is why science is. So I thought this is very important for us to start that discussion on that point, to remember that science is not facts, right? Science is not about just objective realities of laws of gravity. And when we talk about science, immediately that's what comes to our mind, right? We talk about electricity. I mean, those are all things that we discuss in science. Those are all methods that science applies itself to try to find out more answers, to try to understand it better, to understand some phenomena better. So doing science is what we are going from, right? Right now you're learning science in the classroom, and maybe in the lab to some extent you're doing experiments and you're doing some science. But essentially, as a scientist in the future in life, you end up doing science. A lot more of that. Other people may go into engineering. Like I came through high school and I went to an engineering program. I did an undergraduate program in electrical engineering. And then from that, I moved on to do some computer science. So you see, computer science, right? We'll come to that. Why is it science? Why is it not just computer engineering? And from there, I moved on and then started doing robotics for a while, like Gayatri ma'am just mentioned. And from there, now I've come back full circle, and I'm looking at neuroscience. I'm looking at how the brain functions. I'm looking at how behavior is modeled, how we perform certain behaviors, and how that can be modeled. And not just in humans, I'm also looking at it in monkeys to see how monkeys behave and why we can take some habits from monkeys and how that can be applied to understand how humans behave, right? Because after all, we have a certain connection. They are our closest cousins, mostly apes, right? Chimpanzees and gibbons, and chimpanzees and bonobos, not gibbons. Gibbons is slightly further away. Anyway, so coming back to the central conversation, doing science. What is doing science? Doing science is a process, right? And in that process, there are different ways you can do some process. You can do it the good way, or you can do it the bad way, right? So in the similar way, there is good science and there is bad science, and we talk about that very often. But we'll not go into details of how do you know what is good science versus how do you know what is bad science. But rather, we'll discuss on what it takes to critically examine doing science. So when you do science, there are two things: curiosity, that is always in the classroom. Wherever you are, will say, oh, for science, you need curiosity, right? Because for that process to happen, for us to do the process of science, we need to ask questions. Questions are always born out of having a curiosity about something. And from that question, the process of science is about creating, narrowing down that question to something that is something that can be tested. So we create experiments and we test, the questions that we have, and then based on the tests we do, what happens? We receive data, right? Any test you conduct, there is some data produced from that, and we use that data to then look at that question to see, can we now do we have an answer to that question from the data? We do some analysis. So looking at data has now become like the biggest thing in the world. It's the most hot topic right now. If you go into graduate studies, or if you finish your 12th standard and you're going into college, the most important thing is like, okay, what is data science? What is machine learning? What is artificial intelligence? We'll talk a little bit about that today. But essentially, doing science is about having that curiosity, figuring out questions, always, and then the second part, which is more important, just having curiosity is not good enough. You need to have critical examination. You should be able to examine the data critically and to say, okay, has this data, is it representative of the problem? Does it cover all the things I want to look at? Or is the data insufficient? If it is not, or is it being collected in a bad way? And that's where kind of bad science comes into it. So, one of the most um, you know biggest crisis in science that is happening today in the world, and you've probably not heard about it, but all the scientists are talking about it, and it's a big issue. Is that a lot of experiments have been done, a lot of science has been done, but unfortunately, people have spoken like, okay, I collected data and I looked at this problem, and here is an answer. And now somebody else looks at it, and somebody else is collecting data in the same way, in the same process that the last person did. And what is happening? They're not able to get the same results. And then they keep trying and they're still not getting the same results. Then they realize that something was wrong. The way the data was collected, the data was analyzed. So that is one thing about science, right? Science is verifiable. We talk about it. Anybody who tries to do science, if you take a scientific principle and you want to do the same experiment in the same conditions, you should be able to get the same results. Only then we call it science. So that is becoming a big crisis today. So there is issues of reproducibility. You're not able to reproduce previous results, and now there is a huge crisis that people are saying, you know what? Just doing science and talking about results is not good enough. People should also publish, what data they used, how they analyze the data. All of that information should be available, so somebody else should be able to take that data and be able to analyze it and critically examine it. Now, why are we talking about this? Why is this so important for you? So I'll drill again and again on that conversation of why it is important to you, right? Although we're going to talk about saving the planet, in your personal life, all of these things, are what determine the kind of projects you do, the way you do a project. And projects are what you want to do, right? Whether it is in high school, in order for you to stand out, for you to shine, you tend to do projects. You take science projects, you take up other projects that you want to do. If you go into a degree program, again, you have to actively think about what kind of projects do I want to do? Where is that project going to lead me, right? So, in all of these things, the most important question to ask is, am I doing good science? What is good science? And trying to understand that is very important. Now, so these are all things, before even getting into how science and technology is going to save the world, you need to understand what kind of science needs to be done, what kind of technology needs to be developed. So let me ask you a really quick question. You can unmute and speak. If not, I'll give you a few seconds and answer it myself. So I'm going to wait and see if you have answers. Here's, four things. And, can you tell me, in all these four, you know, systems or objects in the world, what produces highest emissions? Is it ships which are running in the seas? Is it cows that are grazing in the field? Is it chocolates, the production of chocolates, how chocolate is made, the process of making chocolates? Or do you think it's like huge rockets being launched into space? What do you think creates the highest emissions?
So I think it is cows because
You think it was cows? Okay.
it's
Why
because
is that?
cows when they release internal gases, it is
Mm-hmm.
no they release internal gases which is not good for environment, and also because
Yes.
when this making of meat also uh, is where emissions.
Yeah.
It causes
Yeah, there's
emissions
a lot of
because
emissions.
meat
Yeah.
productions.
Meat production industry can have emissions. The vehicles coming, that's an excellent answer. Very good. So, vehicles bringing food to feed the cows, when you have big grazing pastures and you need to bring food supplies for cows and you have to drive all these trucks with food supplies and transporting it, all of that creates emissions. So, essentially, cows themselves, also as an engine, when they produce gases from their body, all of that is leading to high levels of emissions. And that's a really good answer, yes. And that is true, actually. Cows do produce the highest amount of emissions. What do you think in all of these four things produce the least amount of emissions?
Ships.
Ships? Are you sure? Do you want to weigh
I
in for
think
another
no
option?
ships, no chocolates.
Chocolates? You want to believe chocolates are the safest thing on the planet? That we don't have any, very poor emissions, so we can actually know it's actually rockets. Because all the rockets do produce high amounts of emission. The duration for which they produce that emission is so limited. Not to mention the number of rockets we send into space is far less than the number of ships in the sea. But even if you take one single unit, the rocket by itself produces very little emissions compared to everything else. So when we look at it, so now I want you to imagine that picture in your mind, right? When we talk about cows and we talk about chocolates and we talk about ships, it's very hard for us to imagine that image of emissions. What does that emission look like, right? Because you don't see the emissions coming out of a cow. You can't see it. You can't imagine it. But you can imagine a rocket taking off. And you have seen how much of emissions is produced under a rocket as it launches out into space. That is visible. Right? When we see every rocket launching, we see huge clouds and large amount of emission happening. If that is actually the least compared to all these other things, one cow versus one rocket, the cow produces more emissions than that one rocket that launches into space. It's pretty crazy, right? To think about it that way. So you must imagine, yeah. So how do we know the answer to this? How do we know that cows produce most emissions? You gave me some really amazing facts. How did we find that answer?
First, collect the data.
Okay, who collected data? Who do you think did it? Whose job would
Uh,
it be to collect data from cows?
I saw this in an article.
You found it in an article. Obviously, so someone wrote that article based on somebody collecting data, right? What kind of scientist would collect data about cows? Do you think? Any
Biologist.
guesses? A
I think
biologist? Yes. Okay, a biologist may do that. An environmental scientist may be interested in that, right? So there are different jobs. It's not one person, it's a team of different people who are involved in these kind of works. So, yes, so different kinds of, people get involved in doing research on these topics, looking at environment, looking at climate change, all of that. So, you see, good science, and when you do science the right way, you can actually not only have answers to these problems, you can try see how you can fix some of them. Here's another one. Who do you think is the best landmine detector? So landmines, I hope you all know what they are. These are these bombs which are planted into the ground and they're almost on the surface. So if somebody steps on it, boom, right? It blasts. These are often left behind after wars because during wars people put it in, but after the war, who's going to go back and take it out? Nobody does. So there are lots and lots of land in different parts of the world which are all infested by landmines. It's a huge problem. There's a lot of land which can be used for agriculture, can be used for different things, but none of that is used right now. Why? Because there's landmines all over the place. In fact, IEEE has a competition that happens. We participated in it once. In fact, one of our team won, I think, at the international level once. From India, we have had two times, I think, the Indian team. I want to say two, maybe three times we won the landmine detection competition using robots. So, robots going and detecting where landmines are and then trying to pull them out. So, what do you think? Who are the best landmine detectors? If you were a scientist and you had to use any of these things, a robot or a beach ball, you know what a beach ball is, right? Like those bouncy balls. Rats or bees? What do you think? Rats. Okay. How do you think rats can be useful?
In Cambodia, because the army used rats, trained rats to find mines,
Mhm.
and
Yes, absolutely. That's a
they
really good
smell
fact.
that they smelled the thing and found this pigment in this landmines.
Mm, right, exactly. So landmines tend to have TNT. You can rats can be trained to smell the TNT. Especially what they use is they use what are called African pouched rats. These are much slightly bigger rats, and they are much easier to train.
Because there
And
is one
yeah.
rat they give this big position in the
Ah, yes. So now here science and technology comes together. You brought in a good point. There is a position involved, right? So this is where you do science to identify which of these systems would be best. What is the problem? How do we figure out how to detect landmine? Maybe we can use smell. Maybe we can smell the TNT, right? Maybe we can see it, but sometimes it's not visible because it's slightly under the ground. So we can smell it. What objects can we maybe use to smell it, and then figure it out? So that is the science. And then technology comes in. So training of rats, and after all of that, putting sensors on them so that when they move around and they detect something, you know their position at any given point of time. So you can have a GPS on the rat and the rat is stopping. So the rats are trained essentially to stop longer around a mine. So that is how you kind of detect, okay, there's a mine there, and then the rat moves on to the next place. But beach balls are also used. I don't know if you're aware of it, but one very simple way to detect landmines is actually to just explode them. They do that. So this was a technique which was used, but it's going away now because there are problems. You could just roll lots and lots of balls. In this particular case, they use the roll some special kinds of beach balls. These are not balls which are just fully beaches, but they're actually made out of pipes. So they're like a structure that can be rolled. It's it's a ball, but it's made out of like pipes joined together. And when you roll it rolls going forward, and it has fins which actually catches air in it. So almost it has sails like a ship. So it uses that and it can roll forward, and as it goes forward, anytime it hits the landmine, it'll explode. And these beach balls are very cheap and easy to make, but then there's a problem, right? The landmine gets exploded. That particular region, you have, material lying everywhere, and then cleaning that up or all of that takes time before you can use that land. But rats are very efficient. In fact, the newest way of doing it is actually using bees. And bees are even more efficient than rats. I'll tell you why. So one of the
because that
problems that
the bees are they like
yeah.
this smell of gunpowder. Because
Ah.
I heard that some bee farmers use gunpowder for.
Mm-hmm. Yes, absolutely. So it's not that they like it; they can be trained to like it. So the way they do it is every time you give it the smell of gunpowder or TNT, you give the bees a little bit of sugar syrup. So the bees can be trained to think that where there is that smell, I will get nectar. And based on that concept, the bees start to go and look for that. Now, why bees are better than rats slightly is because rats are very smart, so they can go around and they can detect the mine and they can move out to the next place. Rarely it can happen that the rat is still moving on the ground. If the rat steps on the mine by mistake, the rat is very light, so it's not heavy enough to explode a mine. But accidents can happen. But bees are not touching the ground, right? Even when they go around things, they're very light, so there is no way they're going to explode the landmine. Second thing is they hover from place to place. So when you let out a group of bees and bees detect the landmine, they all will go and hover around it, and that's the easy way to know there's a landmine over there. So bees are the newest technology that we are using in a way for this business, and you can use robots too. So all of these four things are used, but bees win that challenge when it comes to it. So this is all again a good understanding of science and a good application of technology. Both things have to come together. So often, when we get into like when I got into engineering, at least I can talk on my behalf. I was like, oh, technology is everything. I need to do this and that. But you cannot build good technology if you don't have a good understanding of the science behind it. See, if you understand the science, then doing technology becomes, so you need both. And that's why you don't talk of it independently. I just want to bring in a quote here at this point. So, we talked about good science, we talked about bad science. Terry Sinowski, who's a professor at the university I'm at, and he's a brilliant scientist. He's only one among 7 people in the world who's part of all the 4 national academies of science in the world. So he said, and I think this is a beautiful quote from him, he said, a scientist knows how to solve a problem. A good scientist knows how to best solve a problem. A great scientist knows what problems to solve. So this is something for us to remember, right? So there are some problems that are, you know, solvable by science. There are some problems solvable by technology. Trying to identify what problem to solve. You know, there is this quote you may have heard of it. It says, for someone who has a hammer, everything is a nail. Right? So you have a hammer in hand. Wherever you go, you start. Oh, there's a nail. Everything you start banging with it. Often, as scientists or as people who are doing engineering and technology, we end up becoming those people with those hammers. We go around with what technology we have or what solution or what science we know, and we try to solve every problem with it. No, different problems require different solutions. You need to know with the skills and the technology or the ideas that you have what problem to solve. How does this go back to what you're doing? I've seen so many projects over the years. We've mentored over thousands of students in middle school, 11th, 8th standard, all the way to 12th standard in engineering colleges. And very often the biggest challenge that is there is we say, okay, machine learning can, artificial intelligence can solve all the problems, but no, it cannot. And then we take that one thing that we know and we try to solve, like, okay, let's take solar and put it on every single thing that we can think of. It doesn't work like that. Let's take artificial intelligence, apply everywhere. The projects that are always successful, the projects that get picked up to become the best in the country is always based on this third thing, trying to know what problem to solve with what idea that you have or what technology you have at your disposal. So that is very important. So remember that difference. And that is where, mentorship and other things come in. That is why you have people you can reach out to. How do you know? That's the big question. Like, well, how do I know that's what's the best problem to solve or what problems need to be looked at? There are different places you can go. So organizations like the United Nations, for instance, has put out what is called the Sustainable Development Goals that many of you are now learning in the classrooms. It talks about all the big major problems we have in the world and how all the countries in the world are trying to solve them. Now that tells you what are the big problems to solve, and then how to solve them. You gain mentorship, you talk with your mentors, your teachers, and that is how you come to solutions. And that is why science is never done in isolation. When we talk about scientists, often the image is like Albert Einstein just sitting inside his lab and just cracking away on his own idea alone. It's not always alone. Science is almost always done in collaboration. It's done in discussions. So, even Albert Einstein used to go for conferences and meet with other people, or take anyone, any of the big scientists. They never, sat in isolation figuring out all the answers. They had discussions. They collaborated with other people, and that's very important. Working with other people in your team, bringing a team together, working in a team. This is all very important. That is why all these things are pushed so much. At the level of schools, you say, "Oh, form a team, do a project. Why do form a team? Why can't you do it alone?" You can, but often as a team it helps. Okay, so here, I'm just going to make a slight segue into showing you one of the projects in robotics that we have worked on, and bring back to that problem of good problems versus bad problems to solve, and how do you know? So here is a solution for a robot,
Akshay?
which yes, sorry.
Okay, sorry to interrupt. I think your presentation is stuck. We are still on the best landmine detector slide.
Oh really?
Yeah.
I am moving forward. You can't see me moving
No.
even now.
No, so we can see moving. I think it's problem with the battery, ma'am.
Oh,
But we are able to see, ma'am. Yes.
Okay, awesome. All right. Okay. So yeah. So let us quickly take the segue into looking at this robot. So this is a robot which we designed. Actually, Gayatri ma'am and I and a bunch of other people at Amrita University, were working on this particular robot. It's called the Husky Clear Path robot, and we tried to take this robot into a very rural village in Tamil Nadu. Actually, it was a village in the border between Tamil Nadu and Kerala, near Coimbatore. If you've heard of Valayar, this is close to Valayar. which is at the check post between Tamil Nadu and Kerala. And there is a small community of people who don't have they don't have pipelines coming to their homes. So there is a water tank which gets water from the government pipeline, which comes one time of the day, usually around 3 p.m. And then that tank fills to a certain level, and then everybody comes with cans, like the white can that man is holding, or the small pots that you see, below that, the plastic pots, and they fill it up with water, and they bring it back home. And often they have to carry water. Sometimes, depending on how their house is organized around the pump. Some people have houses closer to the pump. Some people are almost a kilometer away, so they have to move the distance, carrying that water to their homes. So here, we what we were trying to do is we took a robot, and we created a solution where you can have water which is filled on and put on the back of the robot, and the robot can carry it to your home. So I'll show you a quick video, and then we'll discuss about like what is this idea, and then let's do a critical examination of this. Let me know if the video is not working for you. So quickly, let me pause here. So you saw the robot kind of fills water and moves to people's home. Here you'll now hear the robot kind of speaking. It speaks in Tamil. We have some recorded sentences that it can speak, and can it, ask people to like fill water, put it on my back, things like that. I don't know if you're hearing the video, but if you don't, I can explain on top of it. So I'm just going to skip a little forward because we talk about it. So here, I just want to bring this up very quickly. It's not easy to understand in the video, but essentially, people who are working with a robot, and we fill water and send it home, and it was like, oh, this robot is following us home, and we can, get water. We don't have to carry it anymore. Now the robot will carry, 60 liters of water for us. So that's almost 60 kilos, right? 1 kg per liter of water. So this now takes water to our homes. In one trip, we are done. We don't have to carry it anymore. Awesome, right? Then people start getting interested. They're like, oh, how do we recharge this? How often do we have to charge it? How can we use it? Can it carry other things for me? Like people started thinking along those lines. And then we started having like discussions with them and all that. And one of the questions we were asking them, while asking a whole bunch of other questions about how they like the robot, we asked them, what do you think is the gender of the robot? So look at this robot, right? The robot basically doesn't even have a proper face. It just has two eyes on a plastic sheet. It looks like a car, right? And if you heard the voice, I don't know if you're hearing the voice of the video, but it has a very male voice. It's a very clearly, distinctly male voice, which says, show me the way to your house, and fill water on my back, and then when it reaches their home, it will give them a message every day. On different days, one day it will say, oh, don't forget to wash your hands. On another day it will say, oh, you know what? Make sure you store your water in a clean vessel. So it kind of gives different tips on on health and hygiene and how to manage your water resources and things like that. So it's also helping in that way. So we asked them like, what do you think is the gender of the robot? What do you think it looks like? And everybody in that village, man and woman alike, everybody said, oh, it has to be a woman. And we were like, what? It doesn't even look like a human being, right? How can you even tell a gender? And it has a male voice. Why would you call it a woman? So interestingly, the reason they said that was because this is culture. This is where culture comes in. They believed that it is a woman's job in the village to carry water. Usually, it's a woman who goes and fetches water. So if this robot is now going and bringing water for us, it has to be a woman. Right? Cannot be anything else. So what we were trying to do in this was we were trying to use this robot and trying to take like very high-end technology and putting it in a village where they're not really seeing this technology. And we were trying to say, how does it impact their life? What is their, how do they believe What do they believe the robot is? How do they perceive it? And why is this question important? The question is important because we are designing technology, right? We design mobile phones and so many things. Do you think the mobile phone, when it was first designed, it was designed for somebody in the village? No. But everybody's using it, right? Now in every village and every place, people have mobile phones. And the television was it designed for the poorest people who are watching the television now? No. So a lot of these technologies, when they were not designed for the people who are using those technologies now. So that is something that you need to remember. So, designing technologies with keeping people who are going to be eventual users. They may not be the people who have the money to buy it today, but in the future, they may be the people who are using it. And to be able to design something for them. So, this is, that is what we were trying to find out. But now let's do a critical examination. Do you think this is a good solution? Do you think a robot carrying water to the villages is like a very good way of doing this, trying to solve this problem? What do you think? What do you think? Like, would you want a robot which can carry water for you in the villages if you're living in a village? And you think that that's really cool and that's the way you want to do it for the rest of your life? Yes. Let me answer that question very quickly for you. See, a robot is not energy efficient. Right now, it requires a lot of charging. Robot is expensive. It may be a lot more cheaper just to put a pipeline to carry that water to the house. And if you have a tank which is high enough, that gravity can do its job, which is what we do in different houses now, right? So this idea of like bringing robots, eventually when robots become cheaper, it becomes very highly energy efficient, it's a good solution. Until that point, when you critically examine it, this makes no sense. It is not a good solution at all. But it is exciting. Here's another one. I just want to quickly tell you. This is another robot which was designed with it has a mouth. Now this is become there's a new avatar for this robot. It looks very different. It looks more sophisticated. It has AI in it now, and it can like look at people washing hands and say are they doing it right or wrong and all that. But when this version was created, it was not that advanced. But this is a robot where it would give it was put in a school where children were washing hands and it will give them a message saying, oh, നന്നായിട്ട് കൈ കഴുകണേ, wash your hands properly and make sure everything is okay. And when you're done with it, it will give like very good, it'll give, and this positive reinforcement robot for helping, giving a message of how to do proper hand washing and to encourage children to hand wash. That's it. So you can see like children singing songs and
So is it before Corona?
yeah.
This robot.
Oh, this was done way before Corona. This was, I think, done almost a year before Corona. In fact, right now, Gayatri ma'am's team, who introduced me in this meeting, you all know Gayatri ma'am. She's the one who's working on this project. She's guiding a group of students at Amrita University to develop the system, and they're building the robot. The robot has become a lot more intelligent now, and so this was a solution which was developed, I think 1 year before, 1 or 2 years before Corona happened. But then during Corona, it became very famous because hey, now you have a robot which can help you wash hands, right? So here you have a solution which is very interesting, right? It is not necessarily forcing you to do anything. It is not saying, hey, wash your hands, otherwise you're going to get punished. It doesn't. All it is doing is saying, oh, very good job, yay, kaigayan markale, and remember to wash between your fingers, and remember that, and remember this. But, because it is a friendly robot and it's a friendly agent, children now, are loving to interact with it, and we were seeing that more and more children were coming to the washing station and were trying to wash hands so that they can talk to the robot. They can, they would show their hands, the kai karigi, and they'll sing songs and all of that. I don't know if you were able to hear, were you able to hear the audio of the robot video when I was playing it?
Sir.
I'm sorry. I don't use Google Meet anymore. I usually use Zoom. So I actually don't know how to even turn on audio on Google Meet. But anyway, I'm sorry that you could not hear the audio. But children were basically singing songs, and it was very interesting. I mean, you can, if you look for Pepe hand washing robot on YouTube, you will find the same video on YouTube, and then you can watch it, and then you'll see all the songs and details. But essentially, what I'm trying to say is solutions like this, which can be, where technology can come in as a helper, as an aid, or making people's lives better. These are all solutions which can really make a difference. So here we have examples of like how technology can be used in very interesting ways for helping humans. And another system that I was working on for a period of time was like working with these brain surgery robots. These are robots which are used actively to to put electrodes in the brain, to be able to monitor brain activity for people who have brain diseases, and to be able to like figure out how operations can be done. It also helps do the surgery also to fix regions of the brain that may be not functioning properly for people to have treatment. So this is a test that is happening with it based on some of the devices I was designing for the robot at the time. So you can see the domain is wide. In medical sciences, robots are used in the high-end spectrum for something like brain surgery, or for surgery of in your stomach, or your what do you say, like in what is called invasive surgical procedures, going into your body and doing very critical work, but in very tight spaces and very high accuracy. But at the same time, it can be used, for fetching water in a village, or it can be something like a friendly neighborhood robot, like helping children learn how to do hand washing. So the same technology, the same ideas can be used in very different ways to solve very different problems. Now, technology has a role to play in all of this, and this is what I was trying to get at. But one very important thing to remember is, this is said all the time. Technology is an amplifier. What is an amplifier? Amplifier means it just, whatever you give an amplifier, it just increases it, right? It just magnifies it. So technology is like an amplifier. You give it good inputs, it will magnify it. You give it bad inputs, it can magnify it. So it depends. There's the mind behind how the technology is designed and the technology is used, is how technology will produce results. So that is where you come in, right? You as a designer of technology, or you as a scientist, when you're using technology, what you put it to use, based on that, it'll amplify. The same technology can be, like I said, it was a very bad idea to use if you use that robot in village. You can't say, oh, here, take a robot which costs 10 lakh rupee. They need solutions like, okay, put a pipeline and then put a tank, and water will come to my home. Very low cost compared to having a robot. Not to mention robot requires maintenance, and all those things. You put a pipe, once in a while, if somebody is digging and breaks the pipe, you need to maintain. So if the pipe will lay there and it will deliver water every day. So being more, so you must understand, technology is not just high end computer science and robotics and things like that. Everything is technology. The pipe going to your home is also technology. So just to define technology really quickly for you, um, I once was visiting Israel, and I like to tell the story everywhere I go. I talk about it. I met this 11-year-old boy who was he used to do Lego robotics, and he was the Lego League champion of Israel, and he was like competing internationally in Lego League robotics competitions, like the World Robot Olympiad and things like that. And Because he was so good with technology, but he was only 11 years old. I thought maybe I should ask him what he thinks technology is. So I said, like, hey, what is technology to you? You're doing so much technology. And what answer he gave me just blew my mind because I never heard such a good definition of technology. You know what he said? He said, in very simple words, he's only 11 years old, right? But his idea was clear. He said, everything that did not exist the first day that God created the world is technology. So what he was trying to say is like, you know, everything that was there in the natural world, which existed, naturally before man came in and we started building things, is, everything that came after that, everything came after the natural world is technology, which means anything that man has designed or made over time is technology, right? The tools we use is technology. The chair you sit in is technology, and that's why we're sitting in it. The clothes we wear is technology. The watch you use, everything. You wear a pair of glasses. Like sometimes I have to wear glasses when I'm looking at a distance. That's technology. It's helping me do things better. So technology is not just computers. Technology is not just AI and robotics. Technology is everything that we've created that we use to make our life, improve our lives and do things better. Any tool that is used. So technology is a tool, and that tool acts as an amplifier. It can amplify. A pair of glasses helps me see better. Where is it has that purpose. Like there is an example like the knife. A knife in the hand of a thief can be used to stab somebody, but the same knife in the hand of a doctor can save a life. Right? So it depends on how the technology is amplified. So these are things that you have, as a designer of technology, have to be very cautious about and careful about. At this point, I want to show you one more video. This doesn't have audio, but many of you have probably seen this, so I'm going to talk over it. Okay, this was a situation that was unfolding, in the snow caps, in a, and you can see that the mother bear is looking back at her baby, and she's climbing away while you can see the baby's much smaller, got smaller feet, so it's slightly struggling to keep up with mom. So the mom is sort of making her way to the top. Oh, but the baby slid down. That's quite the fall, isn't it? But the baby is trying to get up to the top. So this video became very famous on the internet a few years ago. It went viral, and the tagline it went with was, you know, try till you succeed. Look at that baby trying so hard. But this is quite a dangerous situation right now for the baby. Its mother is already up there. The baby is struggling to make its way up. It's on a very dangerous slope. It's almost there. It's almost reaching the mom. Watch very carefully what is happening now. Watch the mother bear, okay? Okay. What do you think just happened? You saw something happen. What do you think just happened? Go ahead.
The mother bear tries to help her
Alright. So you think the mother bear tried to help the
small
baby
bear.
bear, but the baby bear rather fell. Okay. Let's watch that again, and you tell me if there is anybody has a different opinion, somebody who does not agree with that opinion. Or watch again carefully. What do you think just happened? But watch what's happening. Okay, the baby is also going way down. I know I'll give up. I'll tell you the suspense. Although this is really bad, the baby is going way down. The baby does make its way up to the top.
So when you get a good success, it will hit you back, something like that.
Okay, that's okay. That's a good way to look at it. But in reality, what is happening? What you said before, like mother is trying to rescue the baby. That's like a moral that we can take out of this story. But what is really happening? While we watch that baby try to make her way to the top, and the baby does make her way to the top in the meantime. And towards the end, you may get a clue of what the mother bear did. Very towards the very end of the video. So let's just finish watching this. But while you're watching this, I want you to critically examine what happened. It is almost making it to the top like it did last time. Will it make it up? Ooh, man. Watch. Okay. Do you have any clues of what happened there?
Right, another way.
It ran away. Yes. Why did it run away?
No, sir. Tried another way.
Oh, tried another way to get to the top and it reached the top. But what happened after that? The bears ran away right towards the end. How do you think? Why do you think it ran away? Okay, so we are watching this whole scene unfold, right? And we are like so involved in the scenes, like what's going on here? But who's capturing this video? It's probably a drone, right? And it was a drone actually. So there was a drone capturing this whole video. And you can watch this last bit again. Okay, watch the mama bear. Look where she's looking and see what is happening. She looks back at her baby. She's starting to run away. She looks back up at the drone and she's running away. Right? Now watch this scene again here and see what you see. Look where the mama bear is looking. She's looking at the drone. She looks again at the drone. She's angry. She's trying to save her baby, but she's looking at the drone. That jump that she did was not to actually save the baby. That jump was her showing anger towards the drone, like trying to defend her baby against the drone. This whole scenario, and there is a piece before this, like how the bear actually was climbing up on the left hand side. It could have gone to the top very easily. But the reason it even went to the right is because the drone tried to angle out and take an angle shot to see the bear go up the slope. And then the bear immediately ran in the opposite direction across the slope. This whole drama, this whole hazard almost happened only because of that drone. Only because that drone came in, zooming in on that person, trying to get the best shot it can on the bear, sorry, and trying to get the best shot it can. And the bear ended up almost losing her baby in the process, right? So here, when you look at a video, like here, this is a use of technology, but the way it is being used, obviously, very poor ethics. There was initially it was very viral. It said, like, try to succeed. You know, we always find a different way to make it to the top and all those things. But after some time, somebody paused and said, "Hey, wait. What is actually happening? Why did this happen?" And when wildlife experts started looking, and they were like, "Oh my God, this is an accident created by the drone and the drone operator. He almost caused that, the baby bear its life." And then suddenly, the video exploded in the other direction. So, it became a big like, oh, this is so bad, should not happen. This borders on what, we talk about ethics of how you use technology, and that's very important. So, Porter Stewart, who's a civil rights activist and he's a criminal justice, he's done a lot in the US for civil rights, especially for the black population. He said ethics is the difference between knowing what you have the right to do. In many circumstances, you will have the right to do something, but what is right to do, knowing the difference between the two is ethics. So you may have the right to do something, but in that situation, even if you have the right to do it, is it the right thing to do? Maybe in that situation, that person had rights. He got a license to fly the drone, but was it the right thing to do to try get that shot to zoom in on that bear and try to almost make it lose its life or lose its baby? So this when you look at something, critically examine it and also think about the ethical implications of it. And this is very important. This is something with drones, with any like all these technologies which are exploding now. Ethics is a huge issue. Like robots now going into war. In the future, all the wars will be fought by robots. See, ethics is not a right and a wrong. So there is no very clear right and very clear wrong in ethics. That is why it is so hard to deal with. You can say, oh, robots going into war. People don't have to fight. We don't lose human lives. Yes, but then it's like, who has the most number of robots? Who has the most sophisticated robots? Who has more money to buy bigger robots? They're going to win the war. So, in what direction is that going? What is the ethics of using robots in war? What is the ethics of flying drones like this? There are some things that are obviously wrong. You should not do. But what you have the right to do versus even if you have the right to do something, is that the right thing to do in that situation? Is what you should ask and think about. So coming back, I just want to circle back and wrap up what we were talking about. We talked about, and this is why I told you, like today's conversation, I'm not going to go into lots of videos and talk about lots of technology and lots of science. I want you to really think about when we say, can science and technology save the world? The answer is not what science can save the world or what technology can save the world. It is how science can be done to save the world and what kind of, ethical implications behind technology that can drive for us to save the world? And that is the important question. Yes, short answer, science and technology can save the world. Short answer, no, science and technology cannot save the world. Both of it are right answers. And the reason for that is it depends on the how. The how makes the difference. And especially, you who are going to be designing these things, who are going to be contributing in these areas, you have a huge role to play in deciding how technology is used, how good science is created, all of that. And with that, you can make a difference. And this is where, when I started engineering or when I was doing, high school, I had a lot of ambitions, but I did not really think in these terms. And because of that, my first project, maybe in undergraduate, was not, towards improving, doing good science or improving and doing better technologies. It was just what's the cool thing to do. But cool is important. I'm not denying it. But the cool thing should also be, ethical. The cool thing should also be useful. The cool, thing should be based on good science with good evidence and good data. All of these are really important. And that sort of is where I started going with that. And one other thing for you to remember is, sorry, let me go back one slide here. One thing for you to remember is, how can you get involved, like in this whole, in this whole, what do you say, process? What can you do as a student? Gain skills, technological skills. Gain as many skills as you can as quickly as possible. Be it in medicine, be it in engineering, be it in other fields. Gaining skills will put you in a position to use those skills to make a difference. How do you gain skills? Start with programming in Arduino, start with Raspberry Pi, or start with robotics, or start with something else. Start with doing chemistry, new chemical exam. Start with biology. Start so many different things, different processes. Build an incubator at home. Maybe try to see how you can save some eggs that are going. Who's for a bird that loses a mother. So there's so many different ways you can look at it. But gaining those skills will put you in a position, and that's sort of what I have learned in my life. Like the more and more I've been learning new things and gaining new skills, I've been able to do more and more different things. Like right now, I'm working in using drones to study monkeys moving around in the wild and in sanctuaries, and we are trying to using these videos. We're trying to identify the different individuals, and we're trying to look at, based on that, we can document their health, we can document their lifestyles, and then try to see how we can make, environment that can be better for them. We are able to inform like what kind of vegetation, what kind of forests, are better for these animals and how they use it and how they live their lives. And the more we have a better understanding of that, we can figure out how we can, better, protect their environment and hopefully have, spaces where animals and humans and all can coexist. So that is some part of the work I'm doing. So different things, right? And before that, because I did robotics and I had that skill, I could put myself into looking at now environmental applications for it. So there are different ways to look at it. Earth obviously is amazing. Lots and lots of opportunities, whether you go deep into the ocean and you're doing deep sea exploration, or you're on the surface, or you're out in space. You know, sky. And obviously, sky is not the limit. You can go in different directions with what you want to do, um, and that kind of can be scary at times because you don't know what you want to do. But the important thing, like I said, is to start with what is right in front of you. Don't lose the opportunities in front of you. If there's something you can learn today and you can do something today, just do that. Don't wait for like the best or the ultimate thing to come your way. And I think this is the balance you need to strike. At, becoming good in technological skills, learning what is good science, critically examining things, having a strong set of ethics about it. And ethics is not something it comes from within. Ethics, there is something that you comes from culture, from your parenting and your society. But there's also things that you can read about and learn and understand about how technology, what are the different ethical implications for technology. Invest yourself in learning about these things and having an opinion about it in the world, and that will make a big difference in how you know, grow as an individual. I think we can wrap up here. I'm already 4 minutes beyond time. I'm sorry.
Okay. Thank you very much, sir. That was a very interesting discussion. Thank you very much for your time and for your effort. We had a fantastic time with you. As a souvenir of this great moment, we would like to have a virtual picture with you all. So for that, I request everyone to turn on their cameras. Everyone, please turn on
Let
your
me
cameras.
stop sharing that real quick. Okay.
Everyone, please turn on the cameras. Still, some are left to turn on. Guys, please. Okay, guys, be ready on my count. 3, 2, 1. IEEE. Okay, one more. Just a second. Okay, once more. 3, 2, 1. IEEE. Okay, got it. Thank you.
Okay.
Thank you so much. Yeah.
Okay. So now it's time for Q&A. You guys might be having a lot of questions, right? So feel free to ask you all your queries. Okay. You can start asking your questions.
Akshay sir, good evening.
Yes, sir. Yes, sir. Nice to meet you, sir.
This is Ajit sir. It's a sheer delight to see you after a long time, sir.
Likewise, sir.
Uh, Sir, excellent presentation, sir.
Thank you so much.
So, Akshay, one question for you would be, since you touched upon ethics as an important aspect, so it's not about science or technology, but it's about how do science and technology. So, how can we teach or how can we stress upon ethics when we do science and technology so that it becomes a part of, it becomes a way of thinking? How can we I mean, what should we do so that science and technology and ethics is the part of the thinking culture?
Right. I think for starters, there's already a lot of different initiatives that you can see is becoming more popular now. I think ethics is a topic. Honestly, the biggest shock in human history in terms of ethics probably came when the nuclear bomb was dropped on Hiroshima. I think that really shook the whole world. And from that point on, people really started pausing to think, wait, do we want to create the next nuclear bomb, which is going to destroy a huge city? And, conversations around that started coming. And I think ethics became more central to the conversation even more now because the second bomb sort of that has been dropped into our laps, which we are not even aware of, it's a ticking time bomb, is actually the power that we have in form of data science, in the form of like machine learning and artificial intelligence, which is rapidly changing the world much, much faster than we can imagine. And then slowly now people are starting to understand, hey, we have a lot of data, we are basing all the decisions that we're making and all the systems we're producing, but uh, you know, nobody's talking about the ethics around it. And that I think in the last few years that has become a big conversation. Especially, you can see there's a huge lawsuit running against Google, for instance, in the US, about how they're using our data and constantly using it to give us advertisements and kind of feed information to us. They know every flight we are taking. They know every wherever you are every minute. How important is to protect that data, or how important is it? How should they be given access to utilize that data? What are the rules around it? So slowly, I think in the global forum, discussion around ethics is becoming central. I think even drawing as teachers or as professors in universities, I think drawing attention to those big mega events happening in our in our world to students and making that central to discussion, letting students like start think along those lines. These are things which very often we don't talk about except when there is like a debate competition or something. You bring it up for a discussion. It's like, okay, now let's debate the two sides of it. But no, this is something that's actively shaping the way you are going to make technology in your lives. This is actively shaping the way you are going to lead your lives. And making that sort of a central conversation is very important to how we do things. And I think one of the things we are losing out actively, and I see more and more of that happening in India more than other countries, is that the thrust for gaining knowledge is so much that the thrust of what knowledge to gain, the discrimination is getting lost. Trying to, and we're not pausing to like read articles about opinions anymore. Because to form our own opinion, we need to hear other people's opinion. Ethics is all about opinions. So gaining different perspectives, reading about different articles, getting exposure to that. Schools do put magazines and other things on the table in the libraries, but you know, curriculum or in our classroom practice, that is not what is really pushed, right? So giving enough importance for that, I think, is very important. Often that is what ends up happening. We talk about it. It's a big issue. Like even at University of California here at San Diego, we have now it is becoming more of a debate where we think, oh, undergraduates, it's one of the best universities in the world. You have top students coming to study here from all over the world. But wait, they don't seem to have an opinion of their own on anything. They just know how to write code or they know how to do a project, but they don't seem to have any opinion around it. And that is becoming a big issue because being able to critically examine something, to have an opinion about something, we need to actively engage our minds in that direction. It is a certain part of your mind, your brain that has to develop direction to do it, critically examine. And I think that is has to be very essential to education. We don't have to wait for education to do it. So we as ourselves we can do it by deciding when you wake up that I'm going to start to have opinions about things that matter, not just opinions about I don't want my parents telling me what I want to do. I mean that opinion is important maybe, but that's not the only opinion that matters. You need to have opinions about how the world functions, how you are engaging with the world. Spend time in those directions as well to develop your own abilities.
Any other question from you guys?
Akshay sir,
Yes.
lost connection sir. Sorry sir. The excellent presentation sir. So it kept me thinking, especially the mention about the ethical aspect of science and so on. But in certain instances, it's quite obvious that whether it is, but most of the important issues in science probably lies in that gray area of moderation. We can't decide to abstain from it or indulge in it and so on. For example, stem cell research, or examples search for extraterrestrial life, or kind of habitation of other planets, or the issues on genetically modified organisms and so on. The ethics probably is constantly changing. What is ethics 10 years before probably is not valid today. So that dilemma still exists. So the question is how to solve that dilemma. Does it come? Can the solution come from science itself? For example, from studies of psychology or the studies of sociology, for example, can that, because those are in fact providing solutions to otherwise unlikely areas where science do not apparently have any role to play. For example, in advertising or apparently in promoting a campaign and so on. So, could science give a solution there?
I think it's a very powerful question that you put forward, and it's a very powerful idea. So you basically brought in two elements here. One you were talking about, ethics falling into this gray area, and will we ever have, and it's changing, constantly changing. So will we ever have answers? And the second part of it is like, where can weigh in on all of this? So the first part of it, yes, ethics is a gray area, but if you look at the micro organism to the macro organism, like sort of like when you look at one individual versus one village, of people living together versus one city versus one state, country, and you expand on it, you would see that the ethical rules and ethical functioning changes because multiple things. Ethics, the reason it is in the gray area is because one of the deepest things in ethics is there is culture. So culture has a very important role to play on how ethics functions. Ethics in one culture may not, apply to ethics in a different culture. And we are a multicultural society, and now with globalization, more and more things are going across the world. Like I'm living halfway across the world. I'm literally in an opposite time zone to you. And I've brought my culture from India here, and I'm trying to fit my culture into the culture of the country here and trying to exist in that. So there are things which for me don't seem very ethical. Like for instance, here if you go to anybody's backyard, they'll have 1,000 things just lying there and they'll wasting away. Well, there's so many things in India which we do not have access to. So because I've seen one side of it, when I see the flip side of it, then the ethics around consumption, the ethics around how we engage in different activities, all of these becomes questioning. Um, so the thing is that I have understood that culture has a role to play, and that is why we have such a dilemma around it. One thing, but not just culture. There's so many different elements, but these elements are constantly also changing, like you said, and that is why ethics is changing. Ethics, there is ethics at the individual level, and there will be ethics at the collective level. Collective at different levels, like I said, from the village all the way to the globe. There will be certain global ethics that we agree upon at different points in time. As human beings, I think, we should have opinions, at least about global ethics, and have, we will have to fall into one side or the other side. You can't be sitting on the fence saying, I don't have an opinion, because it matters to you as well if you do not realize it. But at the same time, at the personal level, you can have ethics, right? And those ethics are also variable. We walk on the street, we see somebody falling. Not everybody rushes to help them. Somebody does it, and somebody else just walks away. Now there are so many things that play out in that ethics of somebody helping somebody. Maybe other person's running to because somebody in his family is in the hospital, and then he needs to get there, or he's trying to get some medicine to somebody, or he's a doctor on the way to the surgical table, and he sees somebody falling. He's like, that person who's fallen, somebody can lift him up. I have to save this person. If I don't get there, it won't happen. So the individual as well in that situation, based on so many different factors, and that is why ethics is always in the gray area. But that is why I keep saying have an opinion, because it is the personal ethics that really matters when it plays out in the end. And you should have opinions at different levels, and you should be able to function ethical standards. The second part of it is, which has science does have a role to play. What science does for us constantly, be it psychology of understanding how how we think about the world, or how we engage with, like you said, media, how we consume media and we form opinions. Any of those things, science has a role to play in helping give you more and more clarity on how things are happening, right, in the world. We get more understanding of what we call the objective truth of how things are in the world, and how we function in society, and all of that. So science will give you evidence, and then based on that evidence you form opinions. So that is why science is a, and it kind of goes both ways. There is also the ethics of science, like how do you apply things to good science. So it kind of is a cyclical process.
Excellent, sir. Thank you, sir.
Yeah, you're welcome. Yeah, I mean, just quickly wrapping up, if there's, the only takeaway from this whole thing is, have an opinion, I think, whether you're doing technology or science. And remember that opportunities that are in front of you, constantly engage with those opportunities. When you have skills and you have opinions, you can change the world. You can do things that matter. If you don't have skills and you have lots of opinions, you're not going anywhere. If you have lots of skills but absolutely no opinion, you don't know what to do. So both of those things matter.
Akshay sir. I don't know whether you remember me. I'm
Oh, yes,
from
I do, ma'am.
Sashiri Amrividyalaya, Sudama. How are you, sir?
I'm good. Thank you so much for coming and joining today's talk.
Really, your talk is really very valuable, especially at this time, because everybody is in a dilemma about this. Really crucial talk, sir. Thank you very much for this talk, sir. Okay,
You're
thank
welcome,
you.
ma'am. You're welcome, ma'am. I think it's a very important thing you brought up, which is this time. And I think this is a great time of opportunity. Like, one of the discussions we were having across, there was a meeting with educators from different countries, including like Brazil and, a few South American countries. And I remember the Brazilian representative said something, and I thought it was very valuable. They said, see, what has happened during the pandemic, right? When Corona happened and the pandemic happened, the whole world froze. Literally, nobody could solve that problem. We were helping people to survive with medical science advanced enough to be able to at least give, oxygen and try to keep ventilators and keep people alive. But we did not really have a solution for this problem. We still don't. We're still trying to figure out solutions. This is a global that everybody, every child, all the way to UKG and LKG, and has witnessed that practically there is no going to school, there is nothing happening, and everybody in the world has realized that hey, there are things which we don't have answers to, and we need to work towards those answers. Nobody has an answer, and I thought that's an answer, and I thought that the educator was saying was this is an opportunity. It is an opportunity, especially for educators, for teachers and university professors who always have to. When they go into the classroom, we usually, try to wear the mask. I have all the answers, right? And the students are like, my teacher, if I ask a question, they need to have an answer. This is an opportunity for you to actually bring out and point and see there are things that even the whole world doesn't have answers to. So even in this classroom, there will be lots of things we discuss that we may not have answers to, which I may not have answers for you, or you may not have answers, but collectively we can search out answers, or we can move answers. And I think that is very powerful because it gives the teachers and the student an opportunity to level up, to get to a point to agree that wait, teacher doesn't have to be a person who knows it all, and the student has there's not there are things that even the whole world does may not have answers to, and we can collectively find answers. And for that, it allows teachers to also open up and be connect more deeply with their students. Because there's a live example to show. Like, see, you can't expect me to have all the answers. There are things the whole world is have answers to. But it's the same thing with ethics. You don't have all the answers. You constantly are evolving.
Yes.
That's how it goes.
Yes, sir. Okay, thank you, sir. Thank you, sir.
Yeah, you're welcome.
So, sir, we may call this session to a close. Thank you for taking the time to be with us, sir, despite your hectic schedule. On the behalf of IEEE Education Society Kerala chapter, we would like to present you with a token of gratitude in appreciation for your efforts and presence. Please accept this, sir.
Thank you, Anthony.
The feedback form is of the webinar is shared in the chat box. I request everyone to fill it out.
Thank you so much for having me here today. This is really nice.
It's a pleasure, sir.
Mr. Akshay, thank you so much. A very nice and useful talk to students and all the participants, listeners. Thank you.
Thank you so much.
Yeah.
It's very nice to meet all of you. Although I've not been so actively with students in India. Once in a while I do so. But this was a really nice session. This was a really nice session. I enjoyed all the questions that came, and it was really nice to see some of you had such great ideas, and some of you had such an amount of knowledge and understanding of topics that we were discussing today. It was really nice to engage with all of you.
So it appears that our event has come to a close. Now, and attendees for the presentation. For that, I welcome Dr. Lisha Paul, Vice Chair of IEEE Education Society chapter, to present the vote of gratitude. Over to you, ma'am.
Okay, good evening to one and all present here. An honorable guest, Akshay Nagarajan, respected EdSoc Chair, Varghese sir, then Kasim sir, Vice Chair, Captain, and EXICOM members, coordinator, webinar, volunteers, and all participants. It has been such an honor to be a part of a webinar on the topic Can Science and Technology Help Save the Planet Earth, organized by IEEE. And I'm here of seeing what is good science, bad science, and critical examination, and what is technology from the words of 11-year-old boy is very nice and beautiful answer. Narrated in science is very informative. And on behalf of IEEE Education Society, I extend my gratitude to our honorable guest, Mr. Akshay Nagarajan, to take out of time from his schedule. Thank you for inspiring and encouraging us, the science and technology, with your words. Thank you for wonderful presentation with so many examples and projects also. I express my thanks to Kasim sir, Vice Chair Kerala Section, and Varghese sir, Chair of Education Society, for providing immense support to make the webinar successful. I extend my gratitude to all EXICOM members, coordinator of this program, to organize this webinar. I thank organizing team, volunteers for working hard for the past few days to make this webinar successful. I congratulate all the participants for their active participation. Thank you everyone once again for making it a great success. Thank you.
Thank you, ma'am. And thank you all. I once again remind everyone to fill out the feedback form if you haven't already. With that, we conclude. Once again, I thank you all and have a great day. Thank you, sir. And thank you, everyone.
Thank you. Bye-bye.